Hello everyone, welcome you all to today's class. And today's class specifically we are going to study some concepts. So I'm going to give you concept notes, and it will really help you to study the concepts properly and feeling confident while starting the questions. Yeah. So whenever you start solving the questions now, you will be ready with all the concepts and it will really help you. First thing. Second thing, I want to show you how the ellipse works. It means how the ellipse can be constructed. Okay. So that is the specialty about my this class. So okay, so let me show you first the construction, yeah, formation of ellipse. So I am using Geogebra. So it's in conic section. So I have been taking the Geogebra so to show you, yeah, make you see the conic section, formation of conic section. So here you can see, yeah, just I want to reset everything. Yeah. So here you see, you are able to see the point PXY. Yeah, see the movement of PXY. Whenever PXY, I mean P with coordinates X and Y. So when P is moving like this, you can see every time, no? So it is making, I mean, wherever may be the point, yeah, if you measure distance of P from F1 and distance of P from F2, Pf1 plus Pf2, it will always give you a constant. Okay, and let me show you whenever, yeah, so are you able to see Pf1 and Pf2? Now just observe. I am just taking Pf1. See, this is Pf1. Yeah, got it? Now see Pf2, again Pf2. So what is happening here? Pf1 plus Pf2, that is equal to what? The line segment, right? Line segment with endpoints where it is written vertex. Okay, this is one vertex, this is another vertex. I mean this line segment, complete line segment, I mean length of the line segment equal to sum of the lengths of Pf1 and Pf2. So are you convinced? Are you able to see it? See your Pf1, right, plus Pf2. Yeah, no overlapping. Huh? So here you see Pf1 plus Pf2 is constant. That constant is length of the line segment joining two vertices, right? So we call it 2a. So distance between two vertices, we call it 2a. So it means Pf1 plus Pf2 equal to 2a. And this one you can just see whenever I am moving this. So when at the moment your A and B, I mean Pf1, Pf2, whenever you see F1 and F2, they coincide. What is happening? You are getting a circle, right? I can show you here also. Now here you see, whenever, yes, you see, like this. So, yeah. So in any case, whether it is a bigger circle or smaller circle, you are getting a circle. And you are getting the circle at the moment F1 and F2, they coincide. Your distance between F1 and F2 is 0. Is it clear? Here you see. So it means from this what you could observe. Circle is special case of ellipse, right? Yeah, so circle is special case of ellipse. Now here you see what is happening now. You are getting, I mean when like this, see everything is coming to a point only. Yeah, and here you see in which case you are getting a straight line only. I mean the whole thing is reducing to a line segment. Now you see. So it's very interesting whenever you use technology to study any concept. Okay. So that is the benefit of online study, online teaching. Okay. So now two things you could have seen, first thing you could see, for any point P on the ellipse, Pf1 plus Pf2, that is equal to distance between two vertices. Okay, so if I take vertices as V1 and V2, so Pf1 plus Pf2 equal to V1, V2. And in the concept we will be studying this distance between two vertices, we denote it as 2a. So Pf1 plus Pf2 equal to constant, which is equal to 2a. Second thing we have observed, so it is basically circle is a special case of the ellipse. Okay, so everything is given in NCERT book. If you go through NCERT book also, you will be getting all these things. And here just I am helping you to see the concept as it is written in the book. Okay, now let's go to our concepts. Okay, so here, so mostly, so I have prepared a brief note for you and including all the concepts. Yeah, so visualizing ellipse is done. Now concepts and topic notes. So first of all, coming to the concept, how do we define ellipse? Here we are defining the ellipse in two ways. First one is ellipse is a set of points in a plane whose sum of the distances from two fixed points in the plane always remains constant. So as per this definition, look at the figure. This is the point P. Okay, so P, distance of the P from two fixed points, I mean Pf1 and Pf2. Sum of the distances from two fixed points in the plane always remains constant. So distance of P from F1 is R1, distance of P from F2 equal to R2. It means as per this definition, R1 plus R2 is a constant and R1 plus R2 equal to 2a. As we have seen in Geogebra applet, whenever you are taking this point P, wherever is the, point may be anywhere on the ellipse. So whenever you are just bringing this, moving that slide we have seen in the Geogebra, so Pf1 and Pf2, whenever they are merging with this line F1, F2, so you are getting that what? It is covering the whole line segment V1, V2. Okay, so should I show you once more? Just 1 minute. So if any of you have missed this, let me show you whatever I am saying. Okay, so now you see wherever you are keeping P. Okay, now by moving the slide you can see, okay, Pf1 is this, yeah, Pf1, Pf2, right? So here you see your Pf1 plus Pf2 equal to the distance between V1 and V2, right? Two vertices. Is clear? So sum of the distances, any point on ellipse you take here, sum of the distances of this point from two fixed points F1 and F2 always remains constant. That constant is taken as 2a. Clear? Okay. So going back, yeah, so now these two fixed points are called focal points, or we can say foci. So it is plural of focus. Okay, in case of parabola, we have studied one focus. Here we have two, right? And the midpoint of the line segment joining foci, joining the focal points, is called center of the ellipse. And also this line segment through foci, through foci of the ellipse, this is called major axis. And major axis extends up to V1, V2. The points at which the major axis and the ellipse they meet, these 2 points are called vertices. So V1 is one vertex, V2 another vertex. Okay, so vertices. Okay, so ends of the major axis is what? That is, ends of the major axis are called vertices. So what we have seen in GeoGebra, V1, V2 equal to PF1 plus PF2, right? So we have taken this as 2A. This is your PF1 plus PF2. Here we are taking it as R1 plus R2, right? So sum of the distances of P from two fixed points on the plane always remains constant. That constant is equal to length of the major axis. Clear? Now I was talking about one more definition also. Yes. So here you see the alternate definition of ellipse is: an ellipse is the locus of all those points in a plane such that ratio of their distances from a fixed point, that is called focus, in the same plane to their distances from a fixed line, which we call directrix, in the same plane is always a constant E less than unity. So it means, let me show you what it talks about. So here you see, if you have an ellipse like this, okay, this is one focus and there is a fixed line. Now if you take P anywhere here, okay, so any point P on the ellipse, so distance of P from focus and distance of P from directrix. So whenever you write, suppose it is M. So here PF1 by PM, ratio of the distances of the point from the fixed point, from the focus to the fixed line. This is a ratio. This ratio is called E, eccentricity, which is less than 1. Okay. So in case of ellipse, we have eccentricity less than 1. In case of parabola, we have eccentricity equal to 1. Okay, because any point on the parabola is equidistant from the fixed point, from a fixed point and a fixed line. Fixed point is called focus, fixed line is called directrix. Okay, so because the point on the parabola is equidistant from focus and directrix, ratio of the distances is 1. So in case of parabola, E equal to 1. In case of ellipse, we do have the directrix, fixed line we have, fixed point we have. So this ratio is less than 1. Okay. And similarly, for F2 also you can have another directrix. So it means two foci, yeah, two focal points. So you will have two directrices. Okay. So that is basically to introduce directrix. I just thought maybe alternate definition will work. Okay, next one is equation of the ellipse in standard form. Okay, this is very, you can say, useful, and it will really help you to solve the questions which you always want something, no, we can get some shortcut magic so that we can solve the questions very quickly. Okay, so before going to the standard form, we denote length of the major axis by 2a and length of the minor axis 2b, and focal length, the focal distance, we denote it by 2c. So 2a length of the major axis, that is b1 b2, 2b length of the minor axis, that is b1 b2, and f1 f2, that is focal length, focal distance, it is 2c. Okay, now equation of the ellipse in standard form. So here in standard form, so we take center of the ellipse at origin and major and minor axes are along the coordinate axis. In first case, we are taking major axis along x-axis, center at 0, 0. Okay, so just look at this figure. Yeah, so here equation is x square by a square plus y square by b square equal to 1. Here major axis along x-axis, minor axis along y-axis, center at origin, foci at plus minus C0. It means if this is C0, this is minus C0. So it shows ellipse a symmetric figure. Vertices at plus minus a0. I mean if the length v1 v2 is 2a. So if it is o, I mean origin, o v1 is a. That is called semi major axis. Okay, it is a0 and v2 coordinates are minus a0. b1 coordinates are 0b and here it is 0 minus b. Okay, so it shows ellipse is symmetric about its axis. I mean major axis and minor axis divide the ellipse into four equal parts. Yeah, four portions of equal area. Okay, now let's observe this figure. Yeah, so here you can see as we have seen PF1 plus PF2 equal to 2A, where P is any point on the ellipse. So here I mean any point on the ellipse. So this distance you can see this is your B. Okay, this distance is C. Now B1 F1 that is your under root B square plus C square. Similarly, B1 F2 is also under root B square plus C square. Okay, and whenever you take B1 F1 plus B1 F2 that is equal to 2A. So twice of B square plus C square equal to 2A, or you can say b square plus c square equal to a square. So that is basically why are we studying this. So whenever you are given a b, then you can find c. So it means your b square equal to a square minus c square, or you can say c square equal to a square minus b square. Okay, so it also shows a square is always greater than b square. Okay, and if a square equal to b square, ellipse will become a circle that you have seen in GeoGebra. Okay, I have just shown you whenever f1 f2 coincide, I mean distance between f1 and f2 is 0, it means c equal to 0, right? It means a square equal to b square. So you are getting ellipse is reduced to a circle. Okay, so this will help you to solve the questions. Basically, if you are given the ellipse, you will be given like this: x square by a square plus y square by b square equal to 1. Okay, so you can find c square. So c square equal to a square minus b square. And you can find foci, vertices, length of the major axis, length of the minor axis, everything. On the other hand, whenever you have major axis along y-axis, I have just copied this. Here you can see, okay, major axis along y-axis, minor axis along x-axis, okay, and foci at 0 plus minus C, because major axis contains foci and vertices. Okay, here it will be 0 plus minus C. Just let me rectify this. And vertices at 0 plus minus A. Okay, and everything else remains same. So here you see the figure will look like this. You have the major axis like this. So here you see V1, V2. When major axis along y-axis, what is this V1, V2? 0 plus minus A, right? And minor axis along x-axis, that is B1, B2. Here it is A0, here it is minus. Yeah, let's just change it. B0 minus B0. Okay, and here 0C, 0, minus C. Okay. So, yeah, so how to know whether you are having horizontal ellipse or vertical ellipse? Suppose, for example, you are given x square by 16 plus y square by 25 equal to 1. And in another case, you are given x square by 16 plus y square by 9 equal to 1. Here one thing is very clear, as I have just told you, a greater than b, I mean a square is always greater than b square, right? So in this case, which one will be a and which one will be b? So this one will be a, this is smaller than this, so this is your b square, this one is your a square. It means this ellipse is x square by b square plus y square by a square equal to 1. So this will be your vertical ellipse. Okay. On the other hand, this is greater than this. So this is a square, this is b square. It means it is of first type. So it is horizontal ellipse. Okay. Let me check whether I have just. Okay. So your equation is x square by b square plus y square by a square equal to 1. Okay. So now it is very, very clear. You will not make any mistake. Okay. Depending upon which, I mean the greater one or smaller one, what is in the denominator. Okay. So this is the condition. A square is always more than b square. Okay. So here you see directrix I told you. This fixed line is called directrix. Here it is given. This is directrix. Okay, this is P any point, PF1 and PM suppose. So here you see PF1 by PM. That is eccentricity which is less than 1. Okay, eccentricity is basically we can say ratio of the distances. Whenever you take any point, you may take like this, or the simple definition you can see. So yeah, so if you write here, even if PF1 and if it is V1, V2, so PF1 is to PV1. Okay, sorry. So whenever you take any point, the ratio of the distances of these things, this one is your V1, I mean A. Okay, so here it is eccentricity, we define it as C by A. The proper definition of eccentricity is this. Okay, so it is ratio of the distances of the point from fixed point to fixed line. In case of parabola, P is the point on the parabola is equidistant from focus and directrix. So in case of parabola, we take E as 1, right? So whenever you take fixed point here focus, fixed line directrix, so here we can say the distance between these two, that is 1. And but in case of parabola, we have this is less than 1. Okay. Similarly, whenever you come to this one, yeah, similarly, whenever you take the directrix, so directrix is the fixed line. Okay. Okay, then one more last term. The last term is basically, yeah, latus rectum. So latus rectum is the line segment passing through any of the foci and perpendicular to the major axis. The way you have defined, so this can be taken as latus rectum. Okay. Similarly, this one, you have two latus rectum, plural is lateral recta, LR, ends of lateral recta. Yes. So in first case, in case of horizontal ellipse, it is plus minus C plus minus B square by A. In case of vertical ellipse, it will be what? You can just see in case of vertical ellipse. So here you see, ordinate will be constant, right? Abscissa will vary. So it means here, B square by A plus minus, then plus minus C. Okay, you have two lateral recta. And length of the lattice rectum in both the cases is 2b square by a units. Okay, so these are some of the new terms and you can say topic notes which will help you to solve questions, and in next class we will be taking some questions on parabola as well as ellipse. So till that time, please revise, please feel confident, and in case of any doubt, you can write to me, you can write in the comment box. Okay, and do not forget to like the video in case it is useful to you. Thank you so much.